Welcome to first session of Kubernetes. Today we will see the architecture of Kubernetes as well as the different components of the Kubernetes that we need to know before we start jumping into a deep dive into Kubernetes. Okay. So throughout this session, we are going to cover the basics of Kubernetes, what do actually mean by Kubernetes and why do we require Kubernetes, as well as we will also see installation of Docker on Ubuntu and the basics of containers. Okay, as well as we will also go through the Kubernetes architecture, as well as in the next from the next session, I will start with the installations on Minikube as well as Kubernetes. Okay. As the session progresses, we will see how to create pods, how to create a different type of Kubernetes services like node port, cluster IPs, and all the services. Uh, we will also see what do you mean by replica set and replications controller, and how to create these Kubernetes resources. And also we will go through the deployment. We will go through how to update your applications that is sitting inside your containers from the Kubernetes command line itself. We will also cover the networking part also, as well as the storage part of Kubernetes, how to create volumes and attach to a particular pods. At the last, we will have a small demo or workshop type of stuff, which will which will go through just for the practical purpose. We should clear the ideas of different concepts of Kubernetes. Okay. So today's session will be mostly theoretical. From the next session, it will be complete lab session where we will start installing of setup of Kubernetes. Okay. Uh, so from tomorrow sessions, you should have your lab ready, at least the virtual machines ready. Okay. If you are installing Minikube, you require only a hypervisor on your laptop. So that you can install a Minikube on top of it. But if you are looking for uh, installing up three node clusters or more than one node cluster, you will require three virtual machines. Okay. For demonstration purpose, I will use this time Ubuntu 16.0.4 as a base operating system. Okay, but you are free to choose any other Linux flavor that is supported by Kubernetes to install it. So I will also share the installation guide for other flavors also, so that if you are using some other Linux flavors, so you can also install it out. Okay. So to work in a kube ADM way, you will require at least two virtual machines, but preferably three virtual machines, so that there can be a one master node and two worker node. Okay. You can take the virtual machines from the cloud. So some of the cloud provides free credits, some of the cloud provide free tiers. Okay, make sure you shut down your virtual machines after usage, so that you won't get charged for that, because you are spending your within your free tier limit, or the credit that your cloud gives for some time. Some clouds provide a month credit, some can provide the year credit. Okay, so make sure that you shut down your nodes. Okay. Why I'm not using the um, uh, cloud specific Kubernetes services like AKS, EKS, or GKE. Reason is because you will not get that idea that how to set up your own cluster. Okay, so this is the most uh, deep dive into how to set up your own cluster. Okay, because you might get a chance to work on a private clouds, and private clouds is like company own built cloud. Okay, so in that scenario, you have to install it via kubeadm way, or some way, so that you can install it from the scratch. Okay, so that will give you much deeper knowledge of installing of Kubernetes cluster or setting up your Kubernetes cluster. You can also see that what are the different components that you have installed while creating your cluster. Okay, so let's start with Kubernetes introduction. So you have the knowledge of containers. You know that how to create the containers. The questions comes why we requires even your uh, system like Kubernetes, which is a container orchestration system. That means uh, it manages your containers. Okay, the problem starts when uh, the number of containers on your virtual machines or on a Docker setup or any or different container flavors also rises exponentially. Okay, so suppose you started your own product. Okay, you launch your own product. Okay, and your product is running inside the containers. Okay, tomorrow your product get famous and you need to start scaling it out. Okay, the now you created a you have one node where your containers is residing. You now created another node. You are now creating a third node and so on. Okay, now there are hundreds of containers that is running on your data center. Okay, now the problem starts. How do we manage that? Okay, so what happens if some container crashes out? Okay, how to monitor the health state of each containers? Okay, so are you going to log into each container and check it out? Okay, or are you going to write some APIs which is communicating to the native containers and checking and monitoring the health of states? Okay, then the second problem is that how you will maintain the highly availability stuff, because every time the container crashes out and when you recreate it, it will create a new IP for you. It will create a new internal IP for that. So how will it manage it, the communication between two different services of an entire application? Okay. The third problem is that how you update your applications. Okay. So your application is running on version suppose 3.1, okay, and you have some patches coming in. You have some bug fixes coming in. So every node, are you going to log into each container, delete that container, and start the new container for from the new updated images? Okay, the updated the container images. Are you going to do so manually for this stuff? Okay, so also the problem of the scalability problem. Okay, so how do you know that when to scale? Okay, so how do you identify that? Do you have any system to identify that if you want to scale your application, uh, uh, is it the right time to scale your application, or shall you wait for more loads to come to scale your applications? Okay, uh, the another problem that will come, that how you maintain this highly availability stuff, because you don't know that which container has died on which node and is not working on which particular node, and you have lost your HA capability even though you have spawned the two containers on two nodes. Okay, so these all problems, the solutions comes with Kubernetes. Okay, so Kubernetes is a container orchestration system. That means it manages the entire containers that is sitting on its own cluster. So what it internally does, uh, you take five the number of nodes or number of virtual machines, okay, and that you want to deploy a containers. Okay, so before deploying your containers, what you do, you just create a cluster of Kubernetes on top of it. Okay, by installing the Kubernetes, you just created the clusters, declare one or more node as a master node and other nodes as a worker node. Okay, the purpose of worker nodes where your containers is. Now, if you deploy your containers using the Kubernetes client, okay, which is called kubectl, everything that's like managing, scaling it up, highly availability, auto updating our applications, the updating our application patches and everything is now the responsibility of Kubernetes rather than yours. So you don't have to monitor for your container to die. You don't even have to worry about even if your the one particular node of your virtual machines dies. Okay, so all the containers that are residing on that node will spawn up on some other available nodes. Okay, you don't have to worry about the scalability but features. Okay, as the load increase, you can set up the auto scalability feature where you can auto scale the number of instance of your containers. Okay, so this way you can manage not only hundreds but if required the thousands of containers from a single point of instance, which is called the Kubernetes master. Okay, so this way you are solving lots of problem. Okay, one thing I would like to stress that Kubernetes doesn't create containers. So Kubernetes always require a native container solution for creation of containers, and it supports Docker, Rocket, and Containerd. So there are three container flavors it supports as of today, but it might happen that the fourth or fifth flavors might also get into it. Okay, so it's not like the new containers are not coming in the market. Okay, recently we have seen that last year I suppose the Podman has come. Okay, that's the new container flavors. That was on a complete new way to uh, the creator containers, and that's much faster than the others they claimed it. Okay. So this will come and go. So the idea of Kubernetes to manage the containers but not to create the containers. So Kubernetes rely on the native container system to create the container, and it currently supports three container flavors, but in future it might also scale it up and might support a new flavors also. Okay. So its architecture is designed in such a way that even if the you want to integrate a new container systems into Kubernetes, the top level architecture will remain the same. That means all the commands you are typing will not be affected. Okay. So that means that if underlying today you are using a Rocket and tomorrow you want to migrate to Docker, you don't have to do any changes in your Kubernetes resource configuration files, just like YAML file that you have creating in the future, just like to create the containers and everything. So all the commands remain the same. Even the creation of the pods will remain the same, even if you are changing the underlying native containers for you. Okay, so Kubernetes is a open source. Okay, so you can go to its GitHub projects. You can see its source code also. Okay, uh, the meaning of Kubernetes is like in the Greek is captain. Okay, so that's why you are even when you see this Docker logos and all the stuff, you will see the ships actually, and then the Kubernetes becomes the captain of that ship. So they are just monitoring the managing that ships. Okay, that's why the terminology comes from the Greek word called Kubernetes. Okay. So there's a bit quite interesting history of Kubernetes. It started as a Google project in mid 2014. Okay, so Google it started as an internal project because the same problem that I have said just a few minutes back, they are also facing the same issues. And at that time, even Docker Swarm was not came into the market. Okay, so it was not even released. Okay, so they started their internal projects. Okay, to manage all these containers. Okay, and the developers were Joe Beda, Brendan Burns, and Craig McLoughlin. And later on, many other developers also joined this internal project. And then they have created the first releases, and they have released the first in July 2015. Okay. At that time, Docker Swarm was not even released. Okay, Docker Swarm comes in, I think, mid of 2016. Okay, a year later. So Kubernetes is the first container orchestration system that came in the market. Okay, since it was open source and Google has has contributed as a open source project. Okay, so it was free to use by any others organizations also. Okay, so so later what happened that Google partnered with Linux Foundations, okay, and created another company called Cloud Native Computing Foundation (CNCF). Okay, and Kubernetes becomes its first project. Okay, so Kubernetes is the first project of CNCF, and later on there are many projects right now running. All are open sources because it's owned by Linux Foundation itself. Even the certifications of Kubernetes is provided by Linux Foundation itself, the CKA or CKAD. So now it's maintained by Cloud Native Foundation. So it's a still there are lots of developers from different organizations that are contributing to this Kubernetes project because at last it is helping themselves because if some organization is heavily dependent on Kubernetes stuff, so they might give some of the its resources to work on this Kubernetes open source project. Okay, because Cloud Native Foundations or Linux Foundations are non-profit organizations, so they they believe in open source and they believe in working in such a way that the product is accessible to all folks. Okay, so till now we have gone. I think version from 1.0 to 1.19. Okay, it has released, so it has released the 19th version till date. Okay, the development is going very fast and still uh, even if you're looking into 6 months you might get one or two releases in between. Okay, so the new features are getting added very frequently. It is very fast and it is one of the most um, mm, highly debatable this project across this all the among all the open source communities. Okay, so its development is going very fast and and its popularity also growing very fast as day by day progresses. Okay, for the time being, let's forget what Kubernetes is and let's uh, work on. Suppose you have to create your own clustering technology or clustering system that you have need to manage your containers. So how would like to do that? Okay. So what are features you would like to add on for that? Okay. And how would like to manage it? Okay. So if I have to manage a particular n number of nodes, okay. So I will require first, definitely I will require a clustering capability of my system. Okay. The second thing that I have to decide that which type of clusters I need to use. I need to use all active clusters or active passive clusters. Okay. The third thing that I would require to know that how will I maintain or manage all this, mm, all the components that are sitting on that particular node. Okay. So if I have to design or if we have to design as a group and we have to design some clustering technology, what we will do, we have to think on various points. Okay. So I'm just correlating with what Kubernetes is today, and if we have to design that, whether we come very similar to that or whether we differentiate on that. Okay. If you have any idea, you can also suggest that. Okay. So if I have to design it a clustering capability that I can manage the components on a particular node, what I need to know to do, I have to first bring all these nodes into a cluster. Okay, then I have to sign in into either going for all active node or might be one active passive mode. So active one will be the master one, and the passive one is the worker node or a manager of worker node, whatever terminology that you use. Okay, So if I have to design something like that, so what I need to do, sorry, I have to create a cluster for all the nodes. Okay. Then if I choose to for active and passive mode, then I will require some of them to be a master one. Okay. So I want someone to be a master one and others as a worker one. Okay. Okay. Now I have to manage the containers on top of it. So what I need on each worker node. What I will need a system. Okay, wherein I'll need some client here. Okay, some client. Let me expand it. So, or some API which can communicate to my master node. Okay, and this client will sit on every node. Okay, so it will sit on every worker node. So every worker node has one client. So this one has one client. This one has one client. Okay. Similarly, I will have some system that I can use. Sorry, to communicate to my master. Okay, so I will require some level of communications between the master and worker node. So this one is going to communicate with this one and also all the worker node. Okay, I will require some way to do that. Okay? So I will require the different APIs for the worker nodes, different APIs for the master node. Okay, so that the master can send the instruction to the worker node to create your containers and to patches. Okay, this worker node is responsible to connect to connect to a container native API and create the containers. Okay, what else I require? I require some monitoring capability. Okay, so I require this client API to be enhanced and to have this heartbeat also. Okay, so so this heartbeat, what it will do? Periodically, it will send out the state of the all the containers on this every worker node. Similarly, on this is worker node 2. So it will require the similarly capacity of heartbeat also. So that this will require everywhere. So on each worker node itself. So this is the worker node N. So so I will require this capability. So when you send this data back to the master one, I will require some databases to store that. Okay. So I will require some of other databases. I will require my DB. Okay. And this API should call the DB and stores all the information of your heartbeat. Okay. Okay, similar. Okay. I will also require the capability that a user can log into my master or can access my master and give the instructions to create the containers. Okay, but the containers we will create on only on the worker node. So I will require a same or different API gateway another. Okay, might be on different ports. Okay, wherein my end user can send the instruction to them. Okay, something like that. Okay. Now, what else I require? when the instruction reaches to this admin API, I will require it to a system which can process it out. So I will require some level of uh, manager here, okay, container manager here, which can have this capability, so that when the request receives, it can forward to this one, and when it requires, it can then communicate via this API gateway to whichever node I need to place the node. So I will require some level of this capability of something like that end user has, can create the containers. Okay. Similarly, I will require some of other level of, because when the request comes to create, suppose in number of containers, this container manager should know that where to place actually. So I will, this container manager should also have the scheduling capability. Okay, scheduling algorithm. Okay, so that it can decide that which containers to do. Okay. After this one, this also will communicate to databases to persist the data or fetch the data for that. Okay. So this is something like we would like to do that. Okay. Also, what I will need, I will also, this is not in user actually. This you can say that admin user actually only. Okay. Because this will access by only admin. Okay. I will also require. Okay. So what worker node will do? It will create some containers here. Okay. Let's create few containers here. So this is the container one. Okay. So just name. I just name it out. And okay. I will, so this is going to create all these containers. So this is going to create and monitors all these containers. Similarly, if I want to place it out here, so I create few containers here. Okay, that depends on this my container manager where to place it out. Okay, and request is from the admin user. Okay, now I would also need, because your container will contain your applications, so I will also need some user, okay, to access your container. So I will also require some of the users, okay, so that it can access your applications. So that is called end user. So end user can communicate to my containers. Okay. But the problem is that end user doesn't have the access to the containers directly because it's the internal IP. So I will require some network proxy in between. So that's the reason I will require some API, network proxy API that that can that can communicate to the containers, and I also, my end user, for the simplicity purpose, I only need to communicate to my network proxy API. Okay. So if I make some system like this, I will able to create uh, a system which can manage my containers. Okay, something like this. Okay. So let me repeat once again. So I will require on every node some client here. Okay. Every worker node I will require some client here, so that I can communicate to the master one here. The master one should be the communication point, and client will be the, so client will communicate to each other. Okay, so it can be a socket, new socket programming also. It can be web services also. I will require a manager also, which can has the capability to place the node. Okay, send the instruction to the API to place the nodes. I will also require some scheduling algorithm, because there are n number of nodes where to place. I also require to know that. I will require to persist data capability. So I will require some databases here. Okay. I also require the admin API so that some of the user can send instruction to create the container from the outside itself, or from the command line itself. Okay. I also, because these containers contains your applications. Okay. So I require some level of access to your applications via some of others network proxy. Okay. Because until unless this proxy is available, you don't know that where your container is sitting on worker node 1 or worker node 2 or worker node n. Okay. So you require some proxy. So you communicate directly to proxy, and then you can then this responsibility of this proxy to take care of to route your request to the right containers. Okay. So this is pretty much we will require. If you come to this Kubernetes architecture, and if you compare with this one, uh, it's not exactly the same, but we have come nearby almost the same. Okay, might be 50 to 60% by the same. So let's concentrate on how Kubernetes has done that. Okay, so so just like whatever the API, the whatever the API which have developed here, uh, Kubernetes calls it as a API server. Okay, and this is the web services. Okay, this is developed as a web services, and this acts as a sole gateway for your master one. Okay, on the left side is Kubernetes master, on the right side is all the worker nodes. Okay, so this act as a sole gateway, so no one can access to this entire internal APIs without accessing this master API servers. Okay, these API servers act as a both to communicate with the worker nodes also, and the admin client can also communicate and send the instructions. Okay, so this is a single gateway for that. This is a web services. Okay, on the worker node, we have the kubelet. Okay, on each worker node we will have the kubelet, which will be sitting there, which acts as a which acts as a which takes the instruction to create the pods. Okay, it also monitor the health state of all the containers. Okay, so for right now, for consider this as a containers, we will come to what do you mean by pods. Okay, so it takes instructions from this API server and do what the instruction has been said to create a container, to delete a container. Okay, and whatever instruction they have sent. Okay, also it acts as a heartbeat. Okay, for each and every containers, because if container is not working fine, it also, what kubelet does, it also try to restart the container on a particular worker node. So worker node n kubelet will do for worker node n, worker node 1 kubelet will do for worker node 1 containers, restarting of containers on that node. Okay, so it tries to restart it, but if it fails, it will just send back to the API server. Okay, this will just report back. Okay, so that the particular container has failed to restart. So it is up to the API server that how to take remediate that, how to take the action on that. Okay, okay. It also checks the health state of your entire node itself. Okay, if there is a problem, it will stop sending the heartbeat. That means that API server will not receive the heartbeat, and the controller manager here has all the capability to all the decision making capability, that it has a separate subcontroller, like it has a controller to create your pods, controller to create your replica set, replication controller, the deployments and everything. Okay, it also has the capability of the node controller. Okay, that's one of the controller which acts upon when the new node is onboarded on the cluster, or if some node dies. Okay, to remediate the issues when the node dies. Okay, so this controller manager is the main engine of your Kubernetes cluster, and if and all the API server, when it receives information either from the kubelet, receives back the information from the kubelet, or new instruction from the admin client, it goes to controller manager, and controller manager takes the action on top of it. Okay, there is a separate component called scheduler, because scheduler is required because you don't have one nodes here, you have n number of nodes. Okay, so you require an algorithm capability so that you can take the decision that which for container of, suppose for Tomcat container, uh, uh, which node is the best fit at a particular point of in time. Okay, so that depends on the resource availability on each worker node. Okay, so suppose just I'm just giving example from the admin client. I send a request that okay, create this is the image of Tomcat images to create 5 containers for, on your cluster. Okay, the request receives from by the API server, so it sends via the API server, which is the web services. So it make a post call to that. Okay, API servers receives it and sends to controller manager. Okay, now controller manager has a request pending with him to create a 5 Tomcat containers on the clusters. Okay, it has n number of nodes. Suppose it has 10 worker nodes. So controller manager can't take a decision that which node to place. Okay, because it doesn't have this capability. So what it will do, it will ask scheduler that okay, then take this is the first container, Tomcat container. I need to place where to place. Okay, scheduler will run this algorithm. Okay, so what scheduler will do? Scheduler will take all the information from the, because Kubernetes is periodically sending the informations also for its own CPU availability, memory availability, and the storage availability also. And it is also already stored periodically in the databases. So scheduler will take all this information from these databases, okay, uh, which we also call it data store, but we come later. And then what it will do, it will run this algorithm. And when this run this algorithm, and it will try to find out the best fit node for this particular placement. So when it places the first container, now the state of that particular node changes, because now it has a lesser number of RAM because it has created a new container, lesser number of storage also if the container has the external mounted volumes. Okay, lesser number of the CPU because you started some applications. Okay, now with the new data, it will try to place the second one, third one. Okay, so this scheduler has some algorithm that you just give the input, it will send out the output is the best fitted node for at that node. Okay, we'll come to scheduler algorithm a bit deeper into future sessions. Okay, but right now for that, this scheduler component's job is to uh, give me the node which is the best fit for a particular requirement of placing a container. Okay, etcd is a data stores which acts as a databases for your Kubernetes master. Okay, uh, and all the informations, whether it is sent by kubelet as a heartbeat or controller managers have the request to create the containers, are saved into etcd. So it has all the it's saved in the key value pairs. So it has lots of information saved there. Okay, which we it has all the information that is saved there, which we require to run the entire cluster. Okay, just for example, if you have a 4 node in the cluster, okay, and so that means that etcd also has information that there are 4 worker nodes. Okay, if you delete the information of one worker node in from the cluster, uh, the controller manager will always think that there are 3 nodes in the cluster, not the 4 nodes, because you have deleted the entry from this one. Because the container, if controller manager needs the how many worker nodes are there, that it will fetch from the etcd. Okay, so that's why this databases is very important. If something is missing on this database, that means that resource doesn't exist. Okay. Okay, in your slide, I will delete this one because I've taken this over in the last session. So, okay, so it was a bit different. Every time I come with some bit different one. That's okay. Okay, so let's go through each and every component of masters once again, because that is very important, and that you will not get to see when you create when you use the ready-made Kubernetes services from the cloud, just like GKE or EKS. Okay, this will able to see when you install by kubeadmin. Okay, so there are mostly four components on the master: etcd, API server, scheduler, and controller manager. Controller manager has the subcontrollers also. We will see all the subcontrollers in the sessions also. Okay, so etcd is the databases that stores information in a key value pair. So every information is saved as a key value pair. Okay? So that's why it was designed as. And if you go to Cloud Native Foundations web page, it has a separate projects running on it. So that means that if you want to use these databases for your own project also, you can use it. Okay, so it is a complete different individual design out from the Kubernetes architecture, but Kubernetes also uses this etcd databases. Okay, the role of scheduler is to identify this worker node to place container based on node free capacity and other policy constraints. Okay, so based on the availability of CPU, RAMs, or there might become the constraint that okay, I want to place a particular node. I can put a constraint that I want to place on a particular some with some constraint level, like I don't want to place only on the masters one, or I want to place only on the worker node. Okay. By default, when you install this Kubernetes cluster, all the nodes that you create, or the applications, all the containers that you create, the application level containers, that would only be created on the worker node, not on the master node. But you can change the configurations and you can change the settings to allow you to create on the master node, but that is not advisable because of the security reason. Okay, that is not. We will come to 10 lessons later part, and we will come again that why it is not advisable to create containers on the master node, the application level containers on the master node. Okay. Now come to the controller manager here. Okay. So controller manager is the main engine of your Kubernetes master. Okay. Kubernetes master is also known as Kubernetes control plane. So somewhere you will refer to Kubernetes control plane. That means all the components of your master node comes as a bundle. We call it as a control plane. Okay. So they also named as a control plane. So if you see somewhere, if you're reading some articles, if you see the control plane, it means the same. Okay. So controller manager has subcontrollers also, just like they have the node controller. So node controller responsibility to handling a node lifecycle, just like onboarding a new node. Okay. Actions when the node crashes out. Okay. Just like if the node crashes out, because it's a virtual machine, it can crash out. Okay. So what actions required, just like placing all the containers on that node to other node. Okay. So uh, asking other controllers to do that. Okay. Remediate that. So deboarding the node also requires, okay, that the deboarding the nodes also requires comes in line with node control. We have a replication control also. It takes care of the desired number of containers on the clusters. Okay, we will come to replication controller as a separate entire sessions. Okay, so but for now, if end user has sent the instruction, or if the admin user has sent the instruction, or kubectl via kubectl you have sent the instruction to create n number of containers and always maintain that desired state of n numbers of containers, is the replication controller responsibility to monitor the desired number of the desired state of your containers. Okay, the number of the containers. Okay, this is launched as a separate Kubernetes objects or resources, and we will see how to create these components. Okay, and how this replication controller manages this out. Okay. There are other controllers also. We will see in the future sessions the other controllers also. There are other sub controllers also, just like their namespace controller that maintains the namespace. So when we covers the namespace part, we will see that how the namespace containers controller works on it. Okay. The role of API server is to communicate between master and worker nodes. Okay, and also between the different master nodes, and also it acts as a communication with admins for management operations. It's like the instruction to onboard a new node, or the instruction to to create a new containers or instruction to scale up the container, instruction to deploy a patches to the containers, everything. It the all the communication, that single point that reaches in on the master node is the API server. Okay. Okay. Now on worker node, you have the two components. You have actually the three components: uh, the kubelet, kubeproxy, and the pods. Okay. So kubelet, it manages the life cycle of the containers on that particular worker node. Okay, and also ensures that every containers are in healthy state. So it monitors the state of the containers. Okay? We call it as a pods. We will come to pods also. And if something wrong with that, it will also try to restart it. So it won't ask the send back the master to restart it. It automatically try to restart it if something crashes out. Okay, if it failed to restart, then only it reports back to master. Okay. The purpose of kube proxy is a network proxy. So you require the different because you have n tier applications. Okay, so you have a UI tier, you have a DB tier, you have middleware tiers, and all tiers. Okay, every tiers represents is backed by n number of containers, and each containers might be sitting on different nodes. Okay, so it happened that your middleware container can sitting on node 2 and your DB container sitting on node 3. Okay, now this becomes very problematic in the entire clustering system, because these containers, if the container crashes, the suppose a DB container crashes on node 3, it might respawn on node 1. Okay, so you don't know that how to communicate to each other. So this becomes a very problematic state, and with a newer IP address. So how will you maintain that? Okay, so you don't have the static IPs and everything. How do you maintain that? Okay, and you don't have one containers for that. You have multiple containers for that. Okay, so so all these different from different tiers of application you want to communicate between each other. Okay, that's the internal communication. It might be from the UI to API to your middleware APIs to your multiple backend systems. Okay, multiple backend systems. So you require some level of proxy services on top of it. So Kubernetes comes with the services and their services there. Okay, we'll come to that one. So proxy responsibility is to make sure that you can communicate between the different layers of your microservices, so different tiers of your microservices, as well as it is a responsibility of proxy to set the firewall rules so that the end user, the end customer, which is might be sitting on a different outside the cluster, can communicate to your applications. Well, ultimately, your application is deployed on the cluster. Okay, so so end user doesn't have to worry about anything. It only need to know that my IP address is this one, or my domain URL is this one, and this is the and this is the post request or get request I need to trigger, or if it is a website, just I need to know the domain name or the IP address with the port. Okay, or might be only the IP address, and it assumes that by default the port is 80. Okay, so that's the end user needs to know. After that, end user doesn't have to care about anything that is running inside the cluster. Okay, how these containers are across. Okay, but for to make this works, the proxy, what it does, it provides that layers to the end user. So it changes the firewall rules, and it creates all these services that you created via this network proxy, which is also called a proxy. These all stuff is possible because the proxy is there sitting on each worker node. Okay. You will also require a container runtime. Okay, you also require either Docker container, container D, or Rocket container. Any runtime is required on each worker node, so that because then only kubelet can send instruction to create the containers. Okay, now come to one more stuff is like pods. Okay, so why we require pods? Why we created a pods even if you can create the containers? Okay, so pods is basically a wrapper over the container. So your container is still running, but it's running inside the pods, and the kubelet communicates with the pods, not the containers directly. The reason is the only sole reason is because Kubernetes architecture is designed in such a way that it supports multiple container flavors. Okay, so to support multiple native container flavors, if you create a thin API on top of it, okay, so that you send the same instruction to every time, and you don't worry about the underlying containers, which whether it's a Docker or Rocket or Containerd. You require these thin layers actually, or you require a wrapper over the container, which is called a pod. Okay. Now, even if the tomorrow, suppose the fourth container flavors integrates with Kubernetes architecture, the API that Kubernetes needs to be passed remains the same. I don't even need to upgrade this kubelet for that. Okay, because kubelet will communicate directly to the pod, and when this send this instruction, it is sending the same instruction. It is the responsibility of this fourth container to integrate as a plugin to this architecture. Okay, so that pod provides a similar layers for all the containers. Okay, that's why what pod does, pods can contain the containers. Okay, uh, as well as all the network capability, because the kube proxiness requires this network capability of sending firewalls, as well as all the storage capability is now available at the pod layer, not at the container layer. So native storage won't work. Or if you, even if you are creating the container, even if your Docker images has some volumes defined actually, uh, when it spawns up, when it creates the container from the images, it pod makes sure that the pod API makes sure that it is available at the pod layer itself, so that kubelet can directly communicate to that API. Okay, because the way the volume creates in the Kubernetes architecture is common across whatever container flavor you are using. So, so it this way you require this pod level and the storage level capability at the pod level itself, as well as network level capability as pod level itself. Okay, so pod is basically a thin layer wrapped over the containers. Okay, so that means your underlying containers can be any supported one. That doesn't matter now in the Kubernetes architecture. Okay. Okay. So we will see the two way to install Kubernetes. Okay, via the Minikube way. Okay, Minikube can only work on your local laptops or desktops. Okay, it won't work on it on your virtual machines that you have taken from the cloud. The reason is because Minikube requires that machines to have this hypervisor capability enabled. Okay, VMs is a one level up of your hypervisor capability available, because between VMware and hardware virtualization, your hypervisor layer is sitting in between actually. So it is in VM has doesn't have the access of it. Okay, that means that you require your own laptop where you have direct access to the hardware. Okay, the operating system should have direct access to the hardware so that it can virtualize this one. Okay, so you will require for Minikube we require hypervisor capability, as well as it's a single node cluster which acts as a both master and worker. This is good for your practice purpose, and your local setup is required so that you can just log in and just work out it. Okay, we will see how to create this Minikube components. Okay, the another way is the KubeADM way. This is the production grade Kubernetes clusters. Okay, because you don't, you might not require to use the cloud native one also every time, because there are hundreds and hundreds of clouds are there. Okay, and each cloud doesn't support, and there are lots many private cloud there you will get into the scenario where these days nowadays you get into the hybrid cloud structure. Okay, so now the way it is changing, for everyone, every cloud where you don't require we don't need, where the native Kubernetes service is not available, you will install it via this Kubernetes. Okay, so this is the production. Even if that cloud has this native API, just like GKE is available, you can spawn on virtual machines and create your own cluster. Okay, entirely. That's up to you. Okay, I prefer Kubernetes because that's a good learning stuff to do that. To create a clusters and to create everything, because you have a control of everything. You can see every of the entire full stack of your deployments and everything. Okay, so this way we both way, and also you can install this KubeADM on a local setup also, but you will require at least two virtual machines for that, one for master and one for your worker node. So that will you require two virtual machines at least for that. So your laptop should have good RAM, at least 16 GB RAM capability. Okay, and but if you, I will take three virtual machines, raw virtual machines from the cloud, and I will install it there. Okay, it's up to you that how you do that, depend on your resource available to you. Okay. But make sure that if you are using from the cloud, make sure that you don't cross the limit of your free tiers. Okay, otherwise you will get charged, because every cloud works on a pay as you go model. So the if you have a free credit, so it will consume from your free credits. After your free credit expires, you will get to start charging for that. Okay. So installation, I will start from tomorrow. So you just do your required setup. Okay. I will showcase on Ubuntu 16.04. Okay. But you are choose to different flavors also. If you are choosing Ubuntu, you choose only 16 or 18. Ubuntu 20 is the latest editions, and I've heard that in my previous batches that if some one of my students tried on Ubuntu 20, it failed, but when it moved to Ubuntu 18, it worked actually. So right now, just avoid Ubuntu 20 version, which is the latest one. Okay. You can also use the other Linux flavors like CentOS and other flavors also. Okay, if you want to do that. Okay, I will showcase on Ubuntu. Also send you the link if you are using the other flavors of Linux too. You can choose your own flavors. That's up to you.